Hello and welcome to the Unit 3 podcast on section 9.2. Today we're going to talk about how to name molecules.
So here we are again. I'm Mr. Lin.
And I'm Mr. Sakaguchi still. Here we go. So naming binary molecular compounds. So it's binary just like ionic compounds in the sense that there's only two different elements that make it up. And molecular means that it's covalently bonded. For now, these are the only kind of molecular compounds we're going to learn how to name. Later on, at the end of the second semester, we'll talk more about larger ones.
So there are similarities and differences between naming an ionic compound versus a covalent compound. What's similar is they both end in IDE for the second element. But now you also have to deal with prefixes in naming the formula. And that tells you the number or amount of atoms for each of the parts of the compound.
I have nothing to add. The prefixes are here on the right-hand side. You need to memorize these. We never use mono with the first element. It's just the regular name of the element if there's just one of them. If the element's name starts with a vowel at the end, we drop it. So, for instance, carbon, it's called carbon monoxide for CO and not carbon monoxide.
Right.
Just sounds awkward. I threw in naming acids again here because if you think about it from a metal, non-metal point of view, acids could qualify. And there are actually some acids that don't dissociate or behave ionically as much as other acids do. So they kind of fall in this middle category. But again, remember here, the name of the anion dictates what prefixes and suffixes we add to the name of the acid.
Right, and be sure to keep brushing up on this because it will keep coming back.
Yeah, I mean, we're covering it now, but it's going to be recurring the entire year, so save yourself some headaches. One other thing regarding prefixes, do not use these with ionic compounds.
Right, that's a common misconception. They get confused, and that can actually help you differentiate if something's ionic versus covalent.
Exactly. So writing formulas from names is pretty easy to do because the subscripts are going to be whatever the prefixes are. So if you know the prefixes, you know what to add.
So it literally tells you how many of each. So for instance, carbon tetrachloride down there literally tells you there's one carbon, 4 chlorines in the formula.
Right, so the tetra is the 4 for the subscript. For carbonic acid, we can actually use the acid rules to go backwards and figure out what polyatomic ion goes with carbonic.
Well, first off, you'll also notice there's no hydro, so you know it's not a regular binary acid.
So since it ends in IC, the rule, remember, states that ions that end in ATE should have the IC suffix. So carbonic comes from the polyatomic ion carbonate.
Right.
And if you remember carbonate is CO3 with a 2- charge. And remember, you add H pluses to cancel out the negative charge. And because CO3 has a 2- charge, you need 2 H pluses to cancel that out. Hence, H2CO3. And this is something we'll practice, obviously.
Right.
That's it.